Well, let's learn about a new blueprint thing that will move our objects based off the current location. So back in the blueprint for our item, let's search for add actor world offset. So the world offset adds a delta to the location of this actor in world space, which means it's going to take the current location of that actor and then move it based off that value. So I'm going to go ahead and set for delta location. I'll set the Z to 200. If I run it now, oh no, what happened? Well, because blueprint item happens first, whatever happens in here happens before what happens in C++, our code that sets the actor location and rotation overrides it. So it does in fact move it up 200 points, but then it just immediately sets them to that location, which is not what we want. So I'm going to go ahead and comment these out. Actually, I'm not even going to comment them out. I'm going to go ahead and just delete them. So now if I run this and go back to Unreal and save all and compile, they're now floating higher than they were before. It added 200. So it took the current location and added an offset. So this is an even easier way of doing what I had shown you earlier, which is getting the actor location and then adding to it. You could just use this node and do the same thing. Well, let's see what happens if we do this in C++. I'll delete that node. I'll save all, go back into Visual Studio. Oh, how do I do that? Let's go ahead and inside of my begin play function, I'm going to get the actors forward and location. So I'm going to leave those still. So I want to draw the sphere with the vector pointing out of it. So above those, I'm going to add actor world offset. And then just like set actor location, we can just use an F vector. So F vector. And I'm just going to go ahead and do 100. Now let's do 0.f, 100.f, 0.f. Then last parenthesis. So let's go into Unreal, compile, press play. They are now further over to the left than they were before. So we took the current location and then added to it. It's a little boring that we just have the actor moving one time at begin play. Why don't we have it moving while the game's running? So let's try this. Instead of event tick, I'm going to use this add actor world offset. I'm going to copy and paste this down here. And I'm going to move it. Let's go 1 along the Y. Because tick happens every frame, it will move by 1 unit every frame. But then we need to actually draw that sphere. So I'm going to go ahead and copy this location. And instead of separating location out, why don't I just use get actor location? I'm going to copy and paste that in here. So now it will draw the sphere at the actor location. I don't need to worry about this anymore. So I'm going to go ahead and just delete this. I'll delete that too. Let's start out fresh. Let's run this and see what happens. So every frame, it should move the sphere. And it is. Except every frame, it's drawing a new sphere, and those new spheres are remaining. And my game is lagging. My engine's lagging real hard. That's because every frame it is, what are we telling it to do? We're saying draw a sphere, add offset to the world, then draw a sphere. That sphere is set up to remain constantly. It's set to be persistent. So we need to use our modified version of it. Draw a sphere single frame. So I'll take this draw sphere and change it to draw sphere single frame. Now, what this does is it draws that sphere for one frame only, then it goes away. But the next frame, it will draw a new one, which will go away at the end of that frame, so on and so forth. Now we show those spheres moving to the right, moving automatically, and they pass through whatever's there, but they're moving. And it is redrawing that sphere every single frame. Because of that redrawing behavior, these aren't the most performative. If you have enough of them, it's going to slow down your game. But for what we're doing here, just fine. The issue, though, is that this movement is frame dependent, frame speed dependent. So right now with my computer, with that running, that was pretty smooth. Well, if I go into Edit, Project Settings, and I search frame rate, I have used fixed frame rate. I can click on that. And if I set the frames to, say, 15, so I cut the frame rate in half and press play, they're moving, and they're moving slower, noticeably slower. While my frame rate is lower, because if I move around, you can see that it's a lot choppier, they're actually just moving slower. This is bad. This is frame rate dependent. We have access, though, to something that makes it so it's not frame rate dependent. It is simply by taking our move speed, right? In this case, it's just 1, and we multiply it by delta time. So delta time is a value that's passed into tick, which is the amount of time that is passed between frames. So we take 1 times 0.0006 milliseconds, and then it will only move by that amount. So that way it is not frame rate dependent. It happens based on real life time. So I should get a consistent movement. I'll go ahead and recompile again. So my frame rate is still set to be running at 15 frames per second. But if I click run, they're moving way too slowly. Let's go ahead and change this to, let's say, 10. Or let's go 50. Click run. Now they're moving, and they're moving at a much more stable speed. If I go back and change the frame rate back, just turn off use fixed frame rate, turn that off completely. And if I run it now, they're moving at the same speed. So it's no longer frame rate dependent. When moving things in a game engine, it is important that you ensure it's not frame rate dependent. We use delta time to tell us how that works. So just to kind of give you an idea of what we're talking about, we have our move speed, or move rate, I guess, times delta time is the distance to move this frame. In other words, if you have your move rate times delta time, it's centimeters per second, because that's the unit for, centimeters is the unit for Unreal. So we have our move rate, centimeters per second, times seconds per frame, and you end up getting centimeters per frame. So you end up getting the amount of distance it should move per frame. We have this value here, this 50.f. This is a hard-coded value. That's not really what we should do. Instead, let's go ahead and make a variable. Floats move speed equals 50.f. Let's go ahead and use that variable here and recompile it and see what happens. Click run, and it's still doing exactly what we told it to do. Let's go ahead and have it rotate as well. So I'm going to create a variable called floats rotation speed equals 50.f. And let's do add actor world rotation. Now this wants an F rotator. And I want these to spin like a top. So the first value is going to be the pitch, roll and yaw, or yaw and roll rather. Well, so pitch is along Y, so we don't want that. Yaw, we'll do rotation speed times delta time. And then 0.f along the X. Close that parenthesis. And it helps if I did rotation speed. Now we're not going to be able to see this because we don't have a vector pointing in direction of like what front is. So under my draw sphere single frame, let's go to debug macro and we have draw vector single frame, which wants location and endpoint. Cool. I'll copy that, paste, semicolon. The location is going to be, well, we can just do get actor location. The endpoint is going to be get actor rotation plus get actor forward vector times 100f. This is just like we had previously. We got rid of some variables by just using the functions that are built in here. This isn't necessarily good practice, and neither is putting variables down here. But for demonstration purposes, it's fine. And so we now have objects that are rotating. They spin and they move, and it's not frame rate dependent. It's consistent movement. So that's something.